So, this chapter, this whole chapter, is about oblique triangles. What's an oblique triangle? So, we've already solved some triangles this year. What kind of triangles did we talk about? Right triangles. What do you think an oblique triangle is? Not a right triangle. So basically, we're solving weird triangles. Okay? Non-right triangles. Now, what makes solving non-right triangles different? Notice I did not say more difficult, just difficult.
No right angle.
There's no right angles, which causes what?
No trig. Well,
Are we allowed to use SOHCAHTOA?
no.
SOHCAHTOA is out the window. SOHCAHTOA only works with right triangle. Are we allowed to use Pythagorean theorem? No, that only works with right triangles. So Pythagorean theorem, out the window. What makes solving oblique triangles a little bit different is we need different rules. We don't have any tools in our toolbox right now to solve any right triangles. Now, for the purpose of ease, we're going to name them the same way we did with our right triangle. What do we name all of our triangles with right triangles? ABC. Let's do ABC. Let's say this is angle A, which means where's side A going to be? Side A is going to be opposite of it, so we'll put little a there. Does it really matter where B goes? No, let's put B over here, which means where's side B? Over there. And then if this is angle C, this is little c. There's nothing that says A has to be the biggest, or B has to be the biggest, or C has to be the biggest. It's just we're naming angles. When you're drawing them, I personally recommend trying to make them look reasonable. And what I mean by that is, let's say, for example, on a test, I give you angle A is 20 degrees, angle B is 100 degrees, and I say side C, well, I'll say side A. Side A is 15. Let's say this is the given information, right? Your job is going to be to find angle C, side B, and side, right? Well, when you go to draw it, what I mean by drawing it reasonably, there's no reason to put side A, side B. You don't have to put them anywhere that there's no specific spot you have to put them. But I would recommend looking at it and going, well, where do you think I should put angle B? Is this going to be my angle B? Why not?
It's an acute angle.
That's an acute angle. Well, I'd at least make, if I have an obtuse angle, I'd at least make the obtuse angle, put that in place and say, all right, well, this one looks pretty small. Let's put 20 over here, So at least, try. They don't have to be perfect, but at least try to do that. Because there is going to be one basic rule that's going to help us from geometry. If I know this is 100 degrees, what do I know about this side? It's the biggest. Because biggest side has to be opposite biggest angle. Smallest angle also has to be opposite the smallest. That little tidbit is going to help us. And it'll also make life a little bit easier if you do something like that. Does that make sense? So, our job is to solve this. Well, we have a major problem right now, and that is we don't have any tools in our toolbox to solve this right triangle, or to solve this oblique triangle. We don't have SOHCAHTOA, we don't have Pythagorean theorem. We can't use those because we don't have any right angles. So, how do we do this? And I want to show you where the first law comes from. If this was a triangle, can I make a right triangle?
Yeah.
How?
Like down the middle.
Just draw one of the heights, draw one of the altitudes, right? So let's say we draw this altitude right here. We'll call that H, right? All right, well now I have a couple right triangles. Can I build using SOHCAHTOA a trig relationship with that H, say? Well, I'm not going to use angle C, right? Because angle C kind of got cut here, so let's use angle A. So from A, well, am I going to want to use side C here in my calculations? Probably not, because that got cut too. So the only two sides I really have with angle A are this H and the B. Well, from the angle A, if this is my right angle, where's the H? Opposite. The B would actually be, for this right triangle, the hypotenuse. So what deals with opposite and hypotenuse? Sine. So I could write a trig relationship. Sine of angle A would equal what over what? H over B. Right? Now, can I do the same thing for B? What would sine of angle B be? Well, opposite of using this right triangle, what's opposite of angle B? H again. Hypotenuse would now be A. So sine of B would equal H over A. Right? Now, I can simplify these two by just butterflying them. If I butterfly this, I get H is equal to A times the sine of B, right? And if I butterfly this one, I get H would equal B times sine of A. Well, if this equals H, and this also equals H, what has to be true?
Equal each other.
They have to equal each other. So basically what I can do is I can say B times sine of A should equal A sine of B. Now, with just a little bit of simplification to clean this up a little bit, what we can do, let's just get all the A's on one side and B's on the other. So if I leave this sine of A here, bring this A over, leave this sine of B here, bring the B over with that, this is 2/3 of what we call the law of sines. What the law of sines basically says, in the exact same math, if I did the exact same thing, but I just, instead of drawing this altitude, if I just change it and I do, say, this altitude instead, the math becomes exactly the same. And basically what you would get is the third part, which is the sine of C over C. Basically what the law of sines says is if I take the sine of any angle and divide it by the opposite side, I'm going to always get the same ratio no matter what proportion I do. We can use any two parts of this law of sine. Now, I personally like it written this way, with the signs on top and the sides on the bottom. Some textbooks and some math teachers, in fact, like Miss Hedge when she was here, she used to teach it this way, where she put the angle or the sides on top and put the angles on the bottom. It makes absolutely no difference which way you do it. Both of these will work. I personally like this one better, but if you like that, it looks prettier. If you want to use it that way, it works too. So here's how simple the law of sines is. All you need is a pair. And what I mean by a pair is, if you look at the law of sines, you need a full proportion, which basically means I need to know angle A, side A, or angle B, side B, or angle C, side C. You have to have a pair. do I have a pair in this particular problem? Do I have an angle where I also know its opposite side? Where? A. I know angle A and side A. And the reason that's important is basically all I'm going to do is set up a proportion. If I tried with B and I said sine of 100 is to side B. I don't know side B. If I tried it with C, I'd have sine of C, which I also don't know, over side C, which I also don't know. I can't solve this proportion. I've got 3 unknowns here. But I can also set it equal to sine of 100 goes with B, sine of 20 goes with 15. Is this a proportion that I can solve? Yeah. So now I can solve. How do I find side B? All this is becomes a butterfly. The hardest part of this is you just got to be careful typing in your calculator. First off, what mode do I have to be in?
Degree.
These are all degree measurements, right? So make sure your calculator's in degrees. Alright? And all I have to do is type this in. So I have to do 15 times the sine of 100. So I would type that in as 15 times the sine of 100. I'm going to get that answer. And then I have to do what? Divide it by whatever the sine of 20 is. And I know side B has to be 43.2. Okay? I know this is 43.2. Now, in order to find side C, well, I have to have angle C. Can I find right now angle C? How do you know it's 60?
180.
Yeah, don't all the angles still have to add up to 180 no matter what? So these add up to 120, so this has to be 60. So then how can I find side C? Well, I just set up another proportion. And I can reuse sine of 20 is to 15 again, because that's my pair of A's. Now I just say sine of 60 is to little c. And I just set up another little proportion. And what would I type in my calculator to solve that one? 15 times sine of 60, and then divide that by sine of 20. And I get 37.98, 38 basically. About 38. Easy enough? Now, one quick test that I always want you to get yourself in the habit of doing. And this test does not guarantee you have the right answer, but it is a test that if it doesn't work, you know you screwed something up. Does 43 sound like a reasonable answer for this question? Why? How do you know that 43 sounds reasonable? Well, that's the biggest angle, isn't it? So it has to be opposite of the biggest side. Smallest angle has to be smallest side. Middle angle, middle side. Also, there's a rule that the 3 sides, the 2 small ones, have to add up to be bigger than the biggest, right? These 2 have to add up to be bigger than the biggest side, right? Does that make sense? Because otherwise, like, think of it like the triangle wouldn't close. If you had a triangle where this is 20, this is 8, and this is 10, is that triangle gonna be able to be built, kind of thing? No, so these 2 sides have to be, add up to be bigger than the biggest side, right? 2 little easy tests, just to double check. And does it guarantee that this is correct? No. But if you don't have the biggest side opposite the biggest angle, you know you screwed something up. The law of sines is super, super easy. But does it always work? Can we always use it? So here's what I want you guys to come up with. You guys remember geometry, all those proofs that you did? Remember those three letter acronyms that we used? I want you to come up with every single possible one of those you can come up with. What are they? SAS. Well, we'll put this one out here. SAS. Come on, give me more.
ASA.
ASA. Angle, side, angle. Okay. Oops. Oh, I don't want to do that.
Oh, angle.
Angle, side, angle. Okay, fine. Angle, side, side. Okay.
Side.
Side, side, side.
Angle.
I'm going to put angle, angle, angle on here. That's a special one. Okay? What else you got? You're missing a couple.
Side angle.
Side. So that's the same as angle, angle, side. Remember, these work both ways. So angle, angle, side is the same thing as side, angle, angle. Angle, side, side is the same thing as side, side, angle. If you look this up in any textbook, there's a reason they write this and not this. Okay? Now, I'm okay with writing this. Number one, because I think you're old enough to go, all right, it's funny, but we can move on. Two, I actually want you to remember this one. This is a special one. Is there any more? I don't think that's it. I think that's all. I feel like I'm missing one. Okay. So my question to you, if I gave you this scenario, because this is basically what your test is going to be. I'm going to give you 3 pieces of information on a triangle. Your job, solve it. If I gave you angle, side, angle, my question to you, would you have a pair? So angle, side, angle. No, it doesn't. So basically, if angle, side, angle would be, I would give you an angle, we'll call this 40 degrees, and then I would give you a side, 15, and then where would angle, side, angle be? What other angle? Would it be this angle? No, because that would be angle, angle, side, right? So this angle over here would be the one I would give you. If this was the scenario, do we have enough information to set up a proportion? Do I have a pair?
No.
The answer is yes. Why? Can I find the third angle?
Yeah.
Yes. If I'm ever given 2 angles, don't I always really know all 3? And once I find this, will I have a pair? Yes. If I was given angle, side, angle, yes, I would have to find this other angle, which in this case actually works out to be 90, right? Which I shouldn't have done, but whatever. And now I could set up a proportion. Yes? So angle, side, angle, yes. You can solve using the law of sines. If you're ever given an angle, a side, and an angle right away, you will absolutely be able to solve it. How about angle, angle, side? So if I give you angle, angle, side.
Oh, that's pretty tricky. So we had to say it.
So we'll say this is 60 degrees. What's angle, angle, side look like? So maybe I give you this one. We'll call this 80. And then what side would I give you? Either the top or the bottom. Like this would, if I had gave you this one, that'd be angle, angle, side, right? Or if I gave you this one, that would also be angle, angle, side, wouldn't it? So, if I gave you this, do I have a pair?
Yes.
Yeah, I have an 80 and a 10 right now, don't I? So I can set up a proportion. Sine of 80 is to 10 as sine of 60 is to whatever letter that is that I want, right? And I can set up my proportion and I can solve it. So yes, if I'm ever given angle, angle, side, absolutely, law of sine. You can solve those two triangles. Your homework today is all those two cases. Now, I want to talk about the last two, the last three real quick. Angle, angle, angle. Does anybody remember what the theorem angle, angle was used for? If I just give three angles, can I find the sides? Why not?
Proportional.
It'd be proportional. Remember, the theorem angle, angle did not prove congruency. It proved similarity. Because I can make this triangle as big or small as I want, and I'm not changing the angle measurements, right? So, will I ever be able to find the side measurements? No. Angle, angle, angle is actually not solvable at all, because the only thing you can do with angle, angle is proportionality. Okay? How about side, side, side? Will I have a pair? No, I won't know any angles. This one's solvable, but I need to get you another law. It's just not solvable with the law of sines. How about side, angle, side? If I give you a side, an angle, and a side, am I going to have a pair? I have by this angle, I'd have to know this side, wouldn't I? So no pair. So again, side, angle, side, that's one of my rules. It's solvable. It's not yet. Okay? How about the one that spells a bad word? How about angle, side, side? So we'll say this is 70, this is 10, and then this would be 18, right? That's angle, side, side. Do I have a pair? Yes. Do you guys remember in geometry being able to solve proofs? Were you able to use angle, side, angle as one of your theorems?
Yeah.
Yes. Were you able to use angle, angle, side?
Yeah.
Yes. Were you able to use side, angle, side?
Yeah.
Yeah. Side, side, side?
Yeah.
Yes. How about angle, side, side?
No.
Why not?
Doesn't work.
The reason is, while this triangle, if you're given angle, side, side, this triangle right here might be possible. It might not. It also might be possible to build two completely different triangles with a 70-degree angle, a 10 here, and an 18 here. It might be possible to draw two completely different triangles with the same measurements. So it might be possible to build, it might not be possible to build, it might actually be possible to do two. When you did these in geometry, whether you had, did you guys have Strand or Matcher?
Is it you?
Oh, that's right, you guys had me for geometry.
Yeah.
So there was a day that I probably told you, we're gonna skip these until you get to Trig. Well, on Monday, I'm gonna teach you all about these. These are what we call the ambiguous case. It's a special case. The one that spells the bad word is a special case. You didn't get to use it in geometry not because it was a bad word. Like we weren't just saying, no, you can't use this because it spells a bad word. We were saying angle side side, there might be two different triangles that have those same measurements. So how can I say that this is equal to this if I can have two different triangles that have the same measurements? That just doesn't work. So yeah, we need to be able to solve those though here. So right now, the only two you can solve are angle side angle and angle angle solve. On Monday we will talk ambiguous cases. Okay? So everybody take a look at page 16. I haven't given you a single piece of homework all week. Don't even start. There's zero homework for a whole
I
week.
got plans this weekend. And you're
You
gonna
do not.
Me and Bart here.
Will you
Yeah.
shut your angle side up? See what I did there? You can use that when you get home.
No, I can't.
Yeah, when you're not. When
I'm
you're
pretty
not.
sure you said that same exact thing freshman year.
I probably did.
Probably.
To John.
Probably, yeah.
Anyway, you can't do this
I don't
homework
know.
today, I'm sorry.
All right. On page 160.
Okay.
By the way, visually speaking, this is what your test is going to look like.
I like
It's
it.
just going to be, here's 3 parts of a triangle.
You're already talking
Solve.
about test.
I am. This is
Really?
day 1.
You should calm down.
So,
I think you need to teach.
bring it down a little bit. I'm a little excited.
Talk about it Monday.
I've been bored for a week. You
Yeah,
know.
well,
I
I
have,
have been
so-
your fault.
If you would have came
All right.
yesterday, we would have had issues.
Here's your homework tonight. Giant homework. Page 160. I want you to go all the way to, I'll let you stop at 30.
Every third.
Yep.
Every 30.
10 problems. Every single one is just an angle side angle or angle angle side case. You should have a pair for every single one. What I do ask of you, please answer all of your questions like this. By the way, the first one would be 3, not 1. Okay? You can, and I do actually recommend you drawing a sketch, but if I were to grade those sketches, they get really hard to read because you guys write so darn small. So I want your answers written like this, and it'll also help you later on. So for number 3, they give you angle A is 36. They give you angle B is what, 125?
Yeah.
And then they give you what, side C is 96. So that's what they give you. Do you have a pair? Nope. So what do I gotta do?
Man.
Gotta find the missing angle. How do you find the missing angle? Don't you gotta add up to 180? So what is 180 minus 125 minus 36? Those are the first one together. What is it? 19? I'm taking your word for it. Don't mess with my math. Use it right. Do I have a second? Should we trust John?
It's right.
It's
All right.
Yeah. We're good.
So, where's my proportion?
So many.
So, what is the what is the what? Sine of 19 goes with the 96 as, does it matter which one you do first? Nope, makes absolutely no difference. If you want to do the 36 first, I just put the little A there. I like to keep the letters, don't use X's, it just makes it easier to understand what you're solving for. So, what do I type in here? How do I solve that? 96 times the sine of 36. I press enter to get that answer. And just divide it by the sine of 19. So side A is 173. Seems big. Does it seem reasonable? Well, I mean, side C, even though it had a tiny little angle, was 96. So yeah, it's got to be bigger than 96, right? How do I find the third side? Can I use Pythagorean theorem? No, got to do another
Proportion.
proportion. What's my proportion? Could I do sine of 36 is to that 173?
Yeah.
Yes. I don't recommend doing that. I like to keep going back and using the sine of 19 is to 96 as best I can. Even though it'll work and it doesn't really matter. And in this case, I'm kind of breaking my own rule anyway. It's about confidence. If you screwed something up and that 173 is actually wrong, if you use a wrong answer to find another answer, what's going to happen to your next answer? It's also going to be wrong. So I try as much as I can to never use an answer that I calculate, even though we did have to calculate the 19. But I am pretty sure we subtracted correctly, right? Even though we kind of trusted John to do it. So, you know, it's about confidence. So what's the answer to B?
241.5.
241.5? Easy enough? I seriously don't think you're going to have much of a problem with law of sines. Law of sines is easy. It's never going to get any harder. Law of sines is an easy thing to do. Cool?